Hello, today's lesson is going to be on exponential functions. The definition of an exponential function says let a be a positive real number other than 1. The function f of x equals a to the power of x is the exponential function with base a. So that means that anything to the power of x, as long as it's not 1 and as long as it's positive and a real number, will give us an exponential function. Exponential functions increase exponentially. For example, 3 to the power of x. If we plug in 1, we get 3. If we plug in 2, we get 9. If we plug in 3, we get 27. It's multiplying by 3 every time. It's growing exponentially. 1 doesn't work because no matter what your exponent is, you always get 1. So anything to the power of x tells us that it is an exponential function. So even this, it's got some different transformations going on. It is to the power of x, so it is an exponential function. So let's go ahead and graph this. So we're going to look at, we have 2 times 3, and then we had our exponent button. That caret there brings it up for us. X minus 4. I hit that side arrow to get out of the exponent. I hit graph. Right now I'm on Zoom Standard. If you're not, you can hit that Zoom button and then number 6. That takes you to Zoom Standard, which is just your standard window here. So as I can see, this function is going to continue on in both directions on the y-axis. Its range is going to be from negative infinity to infinity. And we can zoom out in a second to see that more clearly. I'm sorry, its domain, I said range. Its domain on the x-axis there is from negative infinity to infinity. Or it can also be denoted all real numbers. If we're looking down from the bottom here, we can see our trace button, and we can scroll down, and we can see our y value. Do you see how it's changing from negative 3.9, negative 3.96, negative 3.98? Keeps going down and down and down. But it's never actually hitting 4 because we have this asymptote on our function. And so for our range, we're looking at the y values. The lowest that we can get is negative 4, and we're never going to touch it. It's our asymptote, but it's going to go up towards infinity. It's going to go up forever. So our range this time, sorry about that before, is going to be from negative 4 all the way up to infinity. Open bracket, or open circle, open parenthesis on that negative 4, because it's not actually touching the negative 4. And if you wanted to, you could zoom out to see that domain, even though it's curving up, it's still going to be going towards infinity. Because it's still spreading out slowly but surely. As you keep going, it will hit those infinite numbers. Okay, laws of exponents. These are important to memorize so that we have them in our head and we can do them as we are going through things. Anything to the power of x, anything that we're multiplying that has those powers, we add the powers. So a to the power of 3 times a to the power of 2 is a to the power of 5. The reason being is because we have 3 a's here and 2 a's there, so altogether that makes 5. If we're dividing, we subtract. Same type of idea, except that if we had a to the 5th, that would be 5 a's over 3 a's. They would cancel off, which is the same thing as subtracting them. So if you forget some of these laws, you could always write them out to remind yourself. A to the x times a to the power of y would be multiplying, because like if we have a to the 3rd 2 times, that means that we have 2 of them, which would mean that we have a total of 6, which is the same thing as multiplying. It's a bit faster that way. A to the x times b to the x, we could put those in parentheses and put them both to the power of x because they are the same thing. And keep in mind, these first 3 rules only work if the base is the same. Like these are both a's or both whatever that is. And then same thing here. If we're dividing, but they're both to the power of x, you could break that off into 2 pieces. All right, these notes are going to be pretty short today. This is our last question for today, and it's a half-life one. We have this function here. You may have also seen it as PERT. However you see it, it's the same type of thing. A0, that represents our initial value. Sometimes principal is also used. And then we, of course, have E. K is our rate, and T is our time. And then AT would be our total final value. Okay, So it says, suppose the half-life. So half-life means that how much it's at after half of the time of a certain radioactive substance is 20 days. So in 20 days, it will have reached half of its life. And that there are 5 grams present initially. So this initially, that's telling us that that's our initial value. That's our A0. This 20 days is a measure of time. So that's going to be our T value. And then it says, when will there be only 1 gram of the substance remaining? So this one is going to be after we actually know the rate. It's saying, in the end, when will there only be 1 left? So first we are given our time of 20, and we know that our initial value is 5. But really what matters is that it's telling us after 20 days, this is our half-life. So that means that no matter what we start with, our total value is going to be half of whatever we started with. So we could pick any number that we wanted to start here, but the easiest way is just to say 1 and 0.5. Whatever we had here ends up as half of that. And we could pick any number because it's just a ratio because we're dividing it anyways. It's going to be 0.5 for our half-life. So then we can plug in the rest of our formula. E to the power of k. Do we know our rate yet? We do not. But we do know our time is 20. And so we can plug in 20. And so I wouldn't have even had to have written this 1 here, but I did just so that we could practice the division. So we get 0.5 equals e to the k times 20. The opposite of e is natural log. So we're actually going to natural log both sides so that we can get rid of that e. So we have ln of 0.5 equals k times 20. So now to solve for k, I divide by 20. And now this is just a calculator problem. So I come over here, I clear out my calculator, and I'm going to start with the ln of 0.5 divided by 20. And I get this decimal here. So I say k is approximately negative 0.034657359. And I'm just going to want to keep that in my calculator so that I don't make any errors. But as you'll see on the AP test, you want to write your steps as you go so that, that the graders can see your work. And I could see your work on a test too. Okay, so now I have my rate. I can go back and actually solve the problem that they want me to. They gave me an initial value, and they gave me what it wants me to end at. I started at 5, I want to end at 1, but I don't know the time. So now I'm just going to take my formula. So I'm starting with my AT value, so that's 1. My final value is going to be 1. My initial value is 5. E, I do know my K value here. It's that negative 0.034 ... but I don't know my time. And so now I can actually just go back in and I can solve. I want to get E by itself, so I divide by 5. I get 1/5. Negative 0.034 ... times T. I'm writing that ... so I remember to plug it in correctly into the calculator. And now to do the opposite of this, I have to do ln to get rid of the E. So I have ln of 1/5 equals negative 0.034 ... T. So let's figure out our ln of 1/5 right now, or I guess we can go ahead and just divide this. I'm going to divide by this K value. Sorry, my pen. Divide. So what I'm going to do is I am going to take ln of 1/5, so that's what I had there, and I'm going to divide it. I can hit that up arrow and I can actually grab that stored value. And I get my answer here. And I'm going to get T equals 46.43, and I'm going to round to the nearest third decimal place. So 9 years. Or sorry, this one is days. So for these half-life questions, the most important thing is to just set up your half-life as 0.5 e and then set up your time to solve for that rate, and then you can plug in your initial and your final values. Thanks so much for watching.